In a past video, we were talking about how to simplify the Redux flow using hooks and the repository pattern. Now we're going to apply the same strategy when we are not using Redux middlewares to dispatch async actions. Let's check out the current use case. We have again a website with some CRUD actions where we can create, update, and delete a customer. But now the data is listed from an API call and persisted on a simulate backend with JSON server when we add, update, or delete a record. Now let's take a look at the code. We're going to start by reviewing the useCustomer API hook, where we can find all the API calls related to the customer entity to perform some of the CRUD actions on the backend. Notice that each API action returns a promise in case we need to run many API's calls in parallel to avoid slowing down our application. This useCustomer API hook will be used by the useCustomer repository. So we will call it inside a constant to use it as a namespace in case we need to work with multiple APIs on the same repository. Then we will have all the repository actions. You must take into account that this design pattern gives us the flexibility for rewriting how we can manage data. We are not creating a Redux common action. It's important also to highlight that the CRUD repository actions are async because we need to await for the API calls inside of each one. Let's check how the list action works. First, we will be dispatched the listing action type with a boolean flag as payload. This flag will be in true to tell the reducer that the listing action has started. This flag is used to display a message on the view that the customer are being listed. Then it is called the list API method to retrieve the customers from the backend. After that, the retrieved data is dispatched to the reducer with the action type list. Finally, the listing flag is set to false for notifying the reducer that the listing action has finished and the data can be shown by the component. For the other CRUD actions, something similar occurs. Let's check the create action. Once the add customer button is pressed, the creating flag is dispatched with a true value. Notice that it is used to display a skeleton card when the record is going to be created. Then the create API method is called to store the record on the backend responding with the create record data that will be dispatched on the global state to show the new record. Finally, the creating flag is set to false to hide the skeleton card. Now let's take a look at the update action. When the update button from the record is pressed, the updating flag is set to true. This state is used for rendering an info alert to show that currently a record is being updated. Then it runs the update API call that returns the updated record for being dispatched to the global state. Finally, the updating flag is set to false to hide the info alert. Something interesting here is that if we dig into the customer card component code, the loader spinner is shown because it's awaiting for the repository update promise to be complete. Remember that the update repository action is an async function, so when it's consumed from the component, we can await for all the running wrapper processes to finish. Lastly, we have the remove action that works very similar to the update action. When the delete button is pressed, again a boolean flag is dispatched to show that the deleting action is in progress. Then it runs the remove API. For this case, it's not necessary to get the API response to delete the record from the state. We can use here the provided ID from the view to dispatch the remove action to destroy the record from the customer state. For the error state, we can see that each API error response is being captured by the repository action. We can simulate an error by blocking the customer API from the browser to show the error alert. Now let's take a look at the reducer. We have implemented the different action types to track when an action is running, runs, and has failed. A very interesting thing is that we can decrease the boilerplate of coding action types using template literal types to make them dynamic and more reusable. Going into the customer action type, we can check how this magic happens. So for the CRUD action types, We need to code them because the payloads will be always different, but for the others we can standardize the error and flag action types by passing as type parameter the name of the entity, in this case customer, to generate the unique type preceded with the customer word. Something similar can be achieved on the customer state type for the flags and error state. In this case, we can make union types to call common types that may be used for any entity state, so we have the ing CRUD action flags and the error message as common types. Lastly, let's check the implementation of the customer repository inside the view. We can see that when the component is mounted, the list method is called to fetch all the customers. Inside the return, we have the updating and removing alerts that are shown on the browser when a record is being updated or deleted. Also, we have the error message to be displayed when an API call fails. The listing flag is used to render the listing message when the data is being fetched, and then the customer state is mapped to render the cards. The create action is implemented on the add customer button, and the update and delete actions inside the customer card component. There is a performance problem with this implementation when having a big amount of records. We're going to try a real use case of 100 records and use the React Profiler Dev tool to measure the amount of renders done by the app. The big problem occurs when I want to update the data of a single card. It also re-renders the rest of the cards despite its data hasn't been modified. It's because I'm calling a state selector into a reusable hook that in this case is in the useCustomer repository. So this hook is called by the main screen component where all the cards are rendered and also inside of each customer card component. So for the reason, when a state update occurs, the useSelector hook is called again by each card component generating a re-render. To avoid this behavior, we're going to create a getCustomerStateSelector function inside the useCustomer repository hook. So with this we will get this piece of state when it's needed. In this case, the main screen is the only component that needs to get the customer's state to render each of the cards. So for this, we're going to call the customer state using the Redux useSelector hook. With this, the useCustomer repository hook will not re-render the view because it is not selecting a piece state every time it's used. Let's check again the React Profiler Dev tool. And yes, with this we have improved a lot the timing of the view rendering. Also notice that only the single card that was updated is re-rendered. To conclude, the repository pattern helps to write async actions with Redux in a more readable way, letting us to track easily the communication with that API and a change inside the application state. The use of template literal types and union types helps a lot to decrease the boilerplate code to writing action types and state types. The fact of having a good name convention for writing action types will be very useful to ease the app debugging. Select pieces of state inside reusable hooks is not recommended because will generate a big amount of unnecessary re-renders if it is called on a long list of child components. Thanks for watching, see you next time.